is up, YouTube? And welcome to another video. In this video, we're going to be taking a look at troubleshooting Kubernetes workloads such as pods, deployments, and services. Now, a lot of the new folks find it really complicated to troubleshoot these things, but the reality is it's actually quite simple. And this video is going to be a long one, but we're going to go through a lot of different scenarios, and you'll see that the train of thought and the pattern of troubleshooting these things is very similar and quite simple. So without further ado, let's go. So line ending issues are issues I encounter at least once a week. When you have developers working on different operating systems, each operating system has its own way of defining where lines end. You can see Windows over here uses CRLF to determine the end of lines. So when you work on Docker containers that run in Kubernetes or any kind of a Linux system, you have to make sure config files, scripts, and sometimes even code and YAML files are set to Aleph. You can do this by going to VS Code, opening the file. You see I have a file here, some script, which just echoes, and you look at the bottom right corner, you will see CRLF line endings. So if we click this, we can then toggle back to LF, and remember to save the file for that to take effect. Now, when you're working with Git source control, Git will automatically check out these files as well. So if a Windows developer comes and checks out the file, it'll automatically switch it back to CRLF. And if a Linux person checks it out, it will set it to Aleph. And this can cause problems because sometimes that file, config file or code file, can end up in a Docker container, end up in your production environment. Your CI/CD can fail and you can have problems in production. To prevent this, at every Git repository, I normally try and create a Git attributes file. Inside that file, I target specifically files like sh files, shell scripts, configuration. You can put YAML files and code files here as well, and that will basically tell Git not to interfere with the line endings and keep things in Aleph if you know your production systems are using Aleph line endings. Now, this will only help about 80% of the cases. A lot of the time files may still end up with the wrong line endings. So when you work with Docker, you might have source files being copied into container images with the wrong line endings. And when you have Kubernetes clusters, you might have config maps and secrets which are being uploaded from a developer machine right into the environment, also containing the wrong line endings. And these can cause weird problems. Now, to show you some of the weirdness, you can see I created a script, basic bash script. I've set the line endings to CRLF in the bottom corner, and I'm going to run a Debian-based container. So when I go into that container and I run that script, look what happens. Bad interpreter, it can't interpret the shebang, and we get no such file or directory. Now, to show you another Linux environment, I created an Alpine-based container, and I'm mounting exactly the same script in, and look, when I execute that one, it just says not found. Now, you could be running a Python application, .NET, WordPress site. You could be trying to load some configuration and you'll get like a file not found, and you'll be pulling your hair out trying to figure out, and meanwhile it's just a line endings that you could switch. So always keep that alarm bell in your head about line ending. So the basic strategy I try and follow is first look at deployments, then look at pods. And for both of those two, we're going to look at status and events. And that's generally enough to cover most of the scenarios when it comes to Kubernetes deployment failures. So now we're going to run through a few scenarios and I'm going to show you how to apply that. Hey man, how's it going? Your deployment's failing. Oh, what are you seeing? Crash. Oh, okay. So let's have a look. So the first thing we're going to do is we say kubectl get deploy. So as I said, we look at the deployment first, and we can see here, now we're going to look at statuses and events. So the first thing, statuses, we can see there's 0 ready out of 2. So we want 2, but for some reason the pods are not being created. So what we do next is we describe. So you always do a get, check the statuses, describe, check the events. So we describe, and we look through and we look at the events, and we can see deployment is trying to scale up to 2. We can also see that there's a desired 2 pods, but they're both unavailable. So now we hop to pods. So we say kubectl get pods, and we can see crash loop back off. So this is a crash loop. Basically, application will be constantly restarted because it's crashing, and normally this indicates 99% of the time it's an application problem. So the developer needs to try and run this container locally first. Make sure the container runs locally before deploying it to Kubernetes. If it runs in local, it should run on Kubernetes unless your configs or something is incorrect. What I like to do next, whenever something is in a crash loopback, we do kubectl get pods, we grab the pod name, and we immediately do kubectl logs on that pod. And that'll tell us the logs for the application, a stack trace or something. And we can see here, this is an Nginx container, and we've got some dodgy syntax in the Nginx configuration. So this gives us an indication, okay, what's wrong? We need to go back to Nginx, we need to go look at our config, and then we can go ahead and fix that, and that will stop the crash loopback. So how's it going? Did that work for you? Oh, it's failing again. Oh, what are you seeing? Oh, some image issue. Okay, well, let's have a look. So first thing I do again, deployments, then pods. We get the deployments. I can immediately see again that there's something wrong with these statuses. We have 0 out of 2 ready. So what we're going to do next is hop over to the describe command. So let's describe the deployment, look at the statuses and events. We can see we're desired again 2, we have 3 unavailable. So obviously Kubernetes is trying to create these containers over and over again. We can also see based on the events, the deployment is trying to scale to 2. All right, and I'm going to clear that out. My next step is to take a look at the pods. So we take a look at the deployment. We know there's something wrong with the pods. So we take a look at the pods and we see error and image pull back off. So interesting. So image pull back off means it's basically backing off the deployment because the image cannot be pulled. So if we take this pod, we say kubectl describe pod. You can describe both deployments and pods. And when we take a look at this, status is first. Remember, status and events. We look at status, we see pending. It cannot deploy. Why not? We look at the events, pull image, Nginx missing. Okay, it's trying to pull an Nginx image with a tag that doesn't exist. It's telling us here that the manifest for Nginx missing is not found. So we have a Docker container image that doesn't exist in the registry. Now, there's 2 types of errors that can happen here. One is it's trying to pull it from a private repository, and the developer has not defined the secret to pull the image. So double check that if you're pulling from private repos. And number 2, the image is just plain missing. So if you do Docker pull locally for Nginx missing, you'll get the same error. So how's it going now? Is all good? Yep, that worked. Okay, so deployment worked. Okay. But traffic is failing. You're getting errors every now and again. Okay, so there's instability. Deployment has worked. So let's take a look again. Deployment, then pod. So I'm going to do kubectl get deploy, and we can see we have ready to. Again, we have the deployment 0 ready. It looks like it's like every now and again there is a pod that's up. So I'm going to do kubectl describe deploy 0 unavailable. They're all up. They're all running. So we take a look at that. We can see that deployment is continuously scaling up and down. Okay, so the next thing I'm going to do is I'm going to take a look at the pods. There's a crash. This one's running. Look at the restart count. So when I said statuses and events, we looked at the deployment. We could see that there were some instabilities in the deployment with the numbers of replicas. It's trying to scale up continuously. We do get pods. We look at the statuses. We can see we have a crashing one. But we have restart counters going up. Now that's why at some point you will always have running pods, but because something is happening, they're continuously crashing. Restart count is going up all the time, and this means that you'll have instabilities, and when these containers are crashing, you might have intermittent network issues, intermittent latency spikes, and things like that. So let's take a look at these pods. kubectl describe pod, and we can see crash loop back off, last state is terminated. and we take a look at the events, we can see liveliness probe failed, status 404. So this application has a liveliness probe defined to an endpoint that possibly does not exist, or the endpoint is not healthy. So I would always advise, if you see liveliness probe and readiness probe failing, make sure you configure and set up these probes correctly, and also run your Docker container locally. Make sure you can hit that readiness and liveliness probe. So how's it going? Is that all good? Running? Nice. So you can send traffic to it? Okay. Okay, did you try run it locally? Okay, so let's take a look. So again, kubectl get deploy. We take a look at the deployment. We can notice again, replicas are not 2 out of 2. We're going to describe deploy. And we can again see everything looks good except for that all our pods are unavailable. There's a mount, there's everything here, and we can see that it's trying to scale up. Okay, so it looks like the deployment is struggling. We say kubectl get pods, and we look at container creating. So sometimes containers can be stuck in a creating state because of various reasons. So if we take a look at the pod, we're going to go kubectl describe pod. Describe is your friend. We can see it's in a pending status, and if we scroll all the way down and look at the events, remember statuses and events, we can see it's trying to set up a mount for config map example config, which is not found. If I do kubectl get config map, notice that there's no config map. So the developer in this case has deployed a pod and without actually deploying the config map. And this can happen with secrets as well. You deploy your app, you forgot to deploy the secret, or the secret exists in one environment and not in the other environment, and you'll have this issue. So this is a simple one. Make sure you deploy your config maps and secrets, and redeploy your application. Hey, how's it going? It's stuck again. What is the status? Oh, it's in a pending status. Well, let's take a look. So again, first thing we do, kubectl get deploy. We notice that we again have pods that are not ready. So the next thing we're going to do is describe that deployment. We take a look and we can immediately see we have unavailable pods, and we desire 2. We can see we're trying to scale up. So there's a problem at the pod level that's preventing this deployment from scaling and meeting its desired state. So I'm going to do kubectl get pods, and we can see here it's trying to create containers, but they're stuck in a pending state. Now, why is that? The only way we'll know is if we describe the pod. So kubectl describe pod, and that prints out everything again, status and is pending, and events. We look at events and we can notice that nodes are not available, insufficient memory. Now there's a bunch of things that can cause pending status like this. One is you might have a node selector where you say, I want to deploy this pod to a specific node that has specific labels on it. That can, when that node is not available, you'll get a pending status for that. The other one is resources that you define in your pod YAML. If you say I want X amount of memory, X amount of CPU, and that condition cannot be satisfied, your pods will go into pending status. The other one is when the scheduler has difficulty. So let's say your infrastructure is running hot. There's a lot of pods running on a machine, and there's not enough space to put your pod because you have some resource limits that you want to, or request values. Kubernetes will not schedule that application. It will go into pending mode because there's just no place to reliably schedule that application. So normally it's a scheduling problem. So in this case, we have insufficient memory. Now, if we go and we say kubectl get deploy, we take that deployment, we say kubectl get deploy, pop the name, say -o YAML. So let's take a look at what's been defined. And when we take a look, we can see here we've defined some resource limits and request values, and we can see the developer has made a typo here and requests a lot of extra zeros, and that is basically trying to overschedule that. So all we need to do is remove those zeros, reapply the YAML file, and we'll be good. So sometimes, you know, you can make these kind of mistakes, and that's kind of what the pending status means. It's all about scheduling. Okay, so that should solve most of deployment and pod related issues on Kubernetes. One other little tip and trick I want to show you guys is about traffic. So when traffic hits the pod, a lot of the times the deployment is successful, but you can't get traffic to the container. So I want to show you guys, I have a deployment running and I have 2 pods running from that deployment. And now we want to troubleshoot and see why developer can't basically request or get access to that pod from a traffic point of view. So what I normally do is I describe the pod. So I say kubectl describe pod, and I notice that the ports that are exposed on the application is port 80. Now sometimes what happens is when developer writes code is they might say the application is exposing port 5000 or 3000 or some arbitrary port on the local machine, but then the container or Kubernetes is actually listening or looking for port 80. So there's port mismatches. So always make sure you run your Docker container locally first. And when you do the Docker run command and you specify the ports, you make sure that you map the port that you're expecting in the browser to match the port of the container. Now, when you describe the pod and you get that port number, you can use a feature called port forward to test that. So we can say port forward and then the name of the pod, and then we're going to port forward to port 80. And then if I open up the browser and I hit that application or use curl or postman or some kind of a traffic generator, I can see that, okay, I can hit that pod on the right port. So that's a good way to confirm that your deployment is exposing the right port to the container. Hey, you back? How's it going? Okay, so your deployment is good? You can send traffic to it? Did you tried port forwarding? You make sure your pod and container is actually listening on the right port? Okay, so now you can't, your other microservice can't call it. Okay, so this is how we look at specifically troubleshooting Kubernetes services, and we've looked at pods and deployments. So now the developer is exposing his application through a Kubernetes service to other microservices or to an ingress controller. And we know that the container is listening on the right port. We can access it through port forward. So the next step is go up to the service level. So we have an example service. We list out, nothing looks obvious here. We can see it's listening on port 80. We know the Nginx or the microservice listening on port 80 as well. So the next thing I'm going to do is kubectl describe service with that service name. Remember, get and describe are your biggest friends. So we look here and immediately I can see endpoints is blank. Now, when you deploy a service uses labels to select the application. So if we take a look at the kubectl get deploy, we can also say show labels. We see we have labels called app, example app on the deployment. But when we describe the service, we see a selector, example app mistake. So the developer made a mistake by putting the wrong selector in. Sometimes you can put the wrong selector on the service, or you can put the wrong labels on the deployment. They both have to match in order for the service to create the relevant endpoints. Hey, you're back. Is it working now? Oh, you're getting connection refused from the other microservice. So the next way to troubleshoot a service, now I can go do again the describe and things like that, but I want to show you how to actually troubleshoot a service using like curl and actually making a request to see if that service works. So I'm going to do kubectl get pods, and I'm going to jump into one of these pods. So I'm going to say kubectl exec-it pod name, and I'm just going to go inside of that one. Now you can go into any container inside that namespace and try and make a request. So I'm going to make a request to our example service, and I notice connection refused. It's trying to call on the service on port 80, and we know that port 80 is being used on the service, and we know that the container is listening on 80 as well. So this means this service could potentially be misconfigured because there's no port 80 being listened on. So that is one way you can jump into pods, use curl to test it yourself. But what I'm going to do is I'm going to say kubectl describe service, And when I take a look at that, I look at the endpoints and I notice that there's the wrong ports. So when we say kubectl get service and we pass in OYAML, we can get out the YAML of definition of that service, and we notice that we're defining port 80, but the target port is wrong. It's 5000. So these are some of the alarm bells when it comes to services. You have to make sure your selector is correct. You have to make sure your port flows all the way from the exposed port to the target port. The deployment has the right port that maps to the container port. And that, if you fix that, you'll be able to make sure that traffic gets into your container through the Kubernetes service. Right, so that should help you create the correct alarm bells to troubleshoot deployments and services on Kubernetes. So remember, deployments first, then pods, look at statuses, then events. If you have a crash loop, look at logs, and for services, make sure selectors and port mappings are defined correctly, even on the deployment and container level. Also, I encourage to always make sure your Docker containers run locally with the Docker run command before you actually go onto Kubernetes. And hopefully that helps you guys. Hopefully you enjoyed the video. Like and subscribe, and let me know down in the comments what sort of stuff you'd like to see in the future. Until next time, peace.